be a pavement or a sidewalk when I finally lay my eyes on you? Someone I've already loved. Will you find your way out of the blue? Will it be my flat or your apart?
Hello. So, welcome to the stream. Uh, in today's stream, I'm planning to solve only hard-tagged problems from Leetcode. The way this is going to work is basically I have picked one problem as a starting point. It is called sum of total strength of wizards. Uh, So basically, what I'm going to do is I'm going to try to solve this problem, and if not, then I will look at the solution and submit it, and then I will move on to the next problem, which is also going to be a hard problem, um, and it can also, and it has to be in a way related to the problem that I'm solving currently. So that's my entire idea. Now we'll figure out how to jump to the next problem as we go ahead. But for now, sorry for the noise. But for now, we have one problem. So how about we start solving it? All right, let's start the first problem for today. Yes, by the way, I'm going to stream for at least 1.5 hours, which means 90 minutes today. Uh, the reason why I will be streaming for 90 minutes is because I have my first minor exam from tomorrow. Tomorrow is my exam from I guess 2:30. I don't exactly remember. Let's quickly open up the mind map and see when do we have the exam. The reason why so, yes, from 2:30 to 3:30 tomorrow we have our first exam. The exam is of leadership. Uh, my plan is basically very simple. I will wake up at around 7 or 8 and then maybe 8, and then after breakfast I'll spend 2 hours trying to understand, trying to finish up everything related to this particular exam. That's all time. That's all the time that I'm going to give to this particular exam. Once that's done, the next thing that I'm going to do is after before the exam, I will also spend some time try to study microeconomics, just a little bit maybe, maybe make some notes and stuff. And then once this exam is done, I will spend my entire day uh, to studying this EV exam. And then before going to sleep, I will also study for cognitive exam, and then I will do cognitive, then I will study for EV, then I will do EV, and then once the EV is done, I will spend my entire day, not entire, my remaining day for the PC. Now PC is from 5 to 6, which gives me a little rest time between the two exams. So once microeconomics is over, I have around 7 hours to study PC, which I think should be more than enough, but I need to do PC before that also. So one option is to do PC today, but after this stream, I don't think I will have enough energy to do anything. But let's see if I will, then I will definitely try that out. Anyways, so how about we make a plan for tomorrow before we jump into the problem solving and stuff. Uh, so I have, we can make a plan. Let's say plan is to wake up and have maybe wake up at 8. Let's say wake up at 7:30 maybe, not 8. 8 is a bit late. Let's wake up at 7:30 and then um, study PC from 8:30 to maybe 10. Or if you have like if you have to do breakfast, then you can do 8 to 9:30. You can do PC. Then you can have breakfast and come back. And from let's say study leadership from 10 to, you can maybe say that 10:30 to 12:30. That would be a lot. That would be more than enough for a leadership. Once I've done leadership, I can come back, and as soon as I come back, I will, let's say from 4:30, study EV from 4:30 to 5:30, right? Something like that. I can do study for EV. Uh, then I can maybe after snacks, just for 1 hour, spend 30 minutes. So it could be, let's say, 6:30. Okay, maybe I can say study cognitive from 6:30 to 7 o'clock, right? And then I can maybe also spend some more time study EV from 7 to 8, or maybe 8:30. That should be all for EV. And then I don't need to do anything. Then I'll wake up and do EV. And once I've done EV, I will come back and then study for EV. Sorry, once I have done cognitive, I will come back and do EV. And then once I've done EV, I will do from 4:30 to 5:30. Let's make notes for microeconomics. Micro, let's make notes for micro from 4:30 to 5:30. Um, and then from, let's say, 6:30 to 8, let's do from 6:30 to 8. Let's also do micro once again and finish it off once and for all. Then I will have to, at any cost, take out some time to do, um, let's say from 11 to 12, I can do PC. And then once micro exam is over, from 11 to 1, I can do PC, and I can also do PC from uh, 3 to 5, and that should be all. After that, then I have my exam in the morning. So I will have to study from, I don't know if I'd be able to study from 7, but I can try. From 7 to 9, I can do CG. And that's pretty much all for CG. After that, I will study blockchain from 11 to 1, or maybe 3 to 5. That should be more than enough. 3 to 5 blockchain. So these are all of my slots that I'm already backing up for the next 4 days. So I don't have a lot of time. In the upcoming 4 days, I will have to spend my entire time trying to study these things, as well as I have to stream every day for some time. I don't know how that's gonna pan out, but I'll have to manage. I really do not have one free second in the entire day, but I'll try. All right, so that's about it. Let's start solving the problem now. Enough of the time management and timetable and shit. Let's come back to the problem. So the problem says, as the ruler of a kingdom, you have an army of wizards at your command. You're given a zero indexed integer array strength. So this is strength, where strength of I denotes the strength of ith wizard. All right, got it. For a contiguous group of wizards, which is a subarray, the total strength is defined as the product of the two values, the strength of the weakest wizard in the group and total of the individual strength of the wizard in the group. So for example, for if I take the contiguous subarrays, then the first contiguous subarray is just 1, and in that case the total strength would be minimum of the current subarray times the sum of the subarray, which is just 1. Similarly, if I take just 3, then it's going to be 3, 1, 2. Then if I take subarray of length 2, then it's going to be something else. If I take subarray of length 3, then I have to sum all the total, I have to find out the sum of all the contiguous subarrays. Okay, so got it. I think the problem is pretty straightforward. I do not have to think a lot for this particular problem. What I can do is find out all the possible subarrays and then um, do minimum times sum and add it. But that will take O of n square time, and I have a constraint that the length of this array is going to be at least, or at max, 10 to the power 5. So if I write a solution that will take O of n square time, it will give me time limit error because of the array size. So I have to figure out a better solution for this particular problem. I cannot be finding out all the possible subarrays. So let's try to think uh, on the board. Let's try to spend some time on the board and try to figure out a solution, try to come up with a solution. Hmm. So I have 1, 3, 1, 2. I do not want to find all the subarrays. At every step, all I want to have is uh, the minimum element of the subarray and the sum of the subarray. I can maybe I can have a prefix subarray which will store this, which can give me the sum of any index in O of one time. So that could be helpful. Plus, the next thing that I want is the minimum. So I can use a stack in that case, and a stack would help me um, get the minimum value of the subarray. Hmm. Hi Kwanit. Hi. Let me think for a couple of seconds and then I'll get back to with the solution. Hmm. Hmm. 1, 3, 1, 2, 5. Hmm. I do not want to get all the possible subarrays because that will take a lot of time. So what else can I do? Hmm. Hmm. There must be some way of doing it. Hmm. Uh, hmm. If I start from here, in that case, I'll get. Hmm, hmm. Oh, maybe I have some idea, which is, let's say this is my array. Now, if I can find out all these arrays starting at 1, so they would be 1, 1, 3, 1, 3, 1, and 1, 3, 2. All right. Now, for the next element, all I need to do is I need to remove 1 from all of these solutions, all of these answers. So I can use my pre-processing, the calculation that I did. So for example, uh, from this I can start maybe from this one. So right here I have 1 and 3. Okay. um, but I have removed 1 from the subarray, so I will say that in this case my minimum was 1 and my sum was 4, right? In case of 1 3, my sum was 4, and here minimum was 1, this was 1, here minimum was 1 and my sum was 5, and here the minimum was 1 and my sum was 6, right? But now what I'm going to do is basically I'm going to say that I've removed 1 from this array. So right now I'm just going to be considering but in that case also I will have to do O of n square because I'm essentially looping over all of these sub answers, which is not a good solution. Hmm. Is there a better way to solve this problem now? There must be a better way. Just need to figure that out. Hmm. 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 When I just have 1 comma 3 as my subarray, in that case what I do is I find out the min, which is 1, and I also find out the sum, which is 4. Plus I could just have this number where the min is this and the sum is this. Plus I just have this. So these are the 3 possibilities that I have with just 2 elements, because it's of course 2 times 2 minus 1 upon 2, 3 times 2 minus 1 upon n into n minus 1 upon 2, right? I have 2 elements. Never mind. It's gonna be 3 times 2 upon 2, which is 3. So I have 3. This uh, is there a way to pre-process stuff? So let's say I have this and I add 1 into my subarray. Now I will have to consider all of these solutions, which is not an ideal case because that's not what I want. Uh, okay, so there is definitely O of n square as a possible solution. There's also and I'm also thinking that there is no O of n solution. I'm pretty sure that there is no solution with O of n, but if there is, that would be really amazing. Anyways, I feel there could be a O of n log n solution. How will I check if there is a O n log n solution? That's my only bet. Maybe this, I'm really unsure if there is a solution with this. 1, 3, 1, 2. If I take, okay, consider all the possible scenarios. Hmm. Uh, hmm. Um, This is not working. My all of my possible solutions are taking O of n squared time, and I do not like the O of n squared time. So let's check out the hint. Consider the contribution of each wizard to the answer. Okay. Okay. So 1, 3, or maybe rather just talk about 5, 4, 6. Then contribution of each wizard to the answer. Okay. It is gonna contribute once as the square times, plus it is gonna contribute at once as the this plus आगे के जो भी numbers है उनमें minimum. So I can sort of have minimum from right here, and I can sort of have prefix from right here, right? And I can get that. That would be its contribution, isn't it? No, it won't be because it still need to. Okay, no, it will. So for example, in this case, the minimum would be 4 times 9, right? Plus, in this case, it's gonna be 5 times 11. 5 times 11, isn't it? Oh no, 5 times 16, 15, right? So this is the contribution of first wizard. For the second wizard, the contribution is 4 times 4 plus 4 times 10. For the third wizard, it's just 6 times 6. So, if I want to get the solution, what I can do is, hmm, uh, contribution of each wizard. So, contribution of first wizard is this definitely. Can I also store this thing? Is it possible to store this thing? Can I say that I have an array that returns me the sums, all the possible sums? It could be 9 or 15. Uh, I feel that would be really weird if I have such an array, isn't it? Mm, so this is contributed by 6. This was just the 5 and 4 thing. I added 6 and it contributed some extra shit. How will I calculate all of this in O of 1? It's almost impossible, maybe. Let's check out another hint. Can you efficiently calculate the total contribution of answer of for all subarrays at index? Uh-huh. Denote the total contribution of all subarray. Total contribution of all the subarray ending at index I as solve I. Can express solve I in terms of solve m for m less than I. Exactly, this is what I'm trying to do. Uh, trying to say that if I know the contribution at this, can I sort of say what would be the contribution at this? Uh, it's kind of weird. Let's try to do it once again. So let's say my subarray is this, or rather, let's just stick to 131. I don't know, maybe I just want to do 132. 1, 3, and 2. Now, in that case, my one subarray is going to be 1 times 1, another one is going to be 1 times 4, another one is going to be 1 times 6. These are all the subarrays that are starting at the index 0. Similarly, I have several other subarrays like 3 times 3 and 2 times 5. These are the subarrays that are starting at index 1. And I have finally this subarray. So now what I want to do is I want to find out if there's a possible way of representing the answer at this index, answer at ith index. So I want to be able to represent the answer at ith index in terms of the answers at the previous indexes. That would solve my problem if I can do that. Hmm. How will I do that? Answer at this index as the these indexes. I just have this really weird thought right now that I just hope the solution to this problem is not in n squared. Because if it is n squared, then I swear to God, it's a very terrible problem. I'm just gonna quickly check if the solution is actually n squared. Because if it is, no, it is on and on. Nah, brute force is accepted. What the hell? So brute force is accepted. That's exceptionally bad. But I do see some solutions in O of n. So that brings a lot of relief because I think there's a solution in O of n also. If I add a number, if I have just 1 and 3, then all I have is 1 cross 1, 1 cross 3, sorry, 1 cross 4, and 3 cross 3. If I add a number 2 there, then I will have to hmm, I don't know how to solve this, but still, ROM collections import DQ. But still, let's try to do the bare minimum things that I know that I will have to do in order to solve this problem. Prefix is going to be strength of 0, prime range. Because this I know that I will have to do. Prefix dot append prefix of -1 plus strength of I. Now this is for that. I also need to see what is the minimum element in that. Okay, so is that can be helpful. Now I need to figure out a possible solution to this. I can also define p as 10 to the power of 9 plus 7 because my answer is going to be a huge number and I have to return the answer. Now I need to just figure out the logic for this. Um, okay. I don't know why I want to try out so badly, though I have no idea. How will I solve it in O of n? Hmm, Mm, I'm not gonna write the code for O of n square because uska to I have clear idea how to do that. So let's just try to find a O of n solution. What is this? I think okay. The basic idea is for each index I we find the range such that nums of I is the minimum value of this range. Then we simply add the subarray which contain nums of I within the range. Okay, maybe this hint is making some sense. For every index, we have to find for every index we find the range such that this is the minimum value of this range. So for example, 1 is the minimum value of this entire range, right? This is Or if you want to solve the problem in a slightly easier way, then 1 is the minimum value of this entire range. So you multiply 1 times the entire sum, which is 3 to 5 plus 1, 6, right? Sum of Savary times sums of I. How to decide the margin of range? If take nearest, less, or equal from both sides, you will miss index 1 with value 4. Uh, we will take duplicated interval 3 comma 5. You have to resolve if we if take one strictly less from left but less or equal. Hmm. How is this solution giving me the answer? Says that I take 1 and I find out the length. So for example, uh, in this particular example only, I have 1, 4, 2, 2, 5, 2, 6. So for example, if I'm at particular index, then I find the leftmost index that is just smaller than 2. So this, and the rightmost index that is just greater than 2. So just this, and then I multiply, then I add all these numbers and multiply them by 2. So if I do the same thing here, I will get the same thing. If I do the same thing here, I didn't get the solution. I need to watch a YouTube video for this because I have no idea how to solve it. किसकी वीडियो देखनी चाहिए? चलो इसकी देखते हैं.
array, and then you have to identify its sum, the total sum of that particular subarray, total of that subarray, and along with this you need to identify the minimum element that exists in that subarray. So once you have, the equation reduces to summation of assuming each element is acting as the minimum element, we identify the sum of all subarrays where this element is acting as that minimum element. If we are able to do this, then our work is done. So the problem reduces to finding out.
Hello guys, I am Hitesh Tripathi and this is a tutorial video for subarray का जो sum है वो return the sum of total strings of all contiguous groups होगा multiply इन सब का जो total sum है, ठीक है। तुम्हें सारी subarrays, suppose total number of subarrays ये हैं, तो तुम्हें ये बताना है, ठीक है। तुम्हें कुछ मिनिमाइज नहीं करना, कुछ मैक्सिमाइज नहीं करना, कोई ऑपरेशन नहीं करना है। तुम्हें सिंपली, अगर तुम्हारे पास कोई मेथड है इम्प्लीमेंटेशन का, यू कैन यूज़ दैट, अदरवाइज यू हैव टू यूज सम स्पेसिफिक अप्रोच। ओके, तो एक बहुत अच्छी अप्रोच इस क्वेश्चन की मुझे देखने के लिए मिली थी, दैट्स व्हाई आई एम मेकिंग दिस वीडियो। तो लेट्स स्टार्ट विद दिस। तो बेसिकली व्हाट आई एम सेइंग इन दिस क्वेश्चन इज, सपोज अब अगर तुम किसी एक सब स्ट्रिंग के लिए निकालने जाते हो, ऑब्वियसली यू हैव टू फाइंड मिनिमम एलिमेंट फॉर दैट सब स्ट्रिंग, ठीक है। तो ऐसे क्वेश्चन जब भी तुम्हें सारी की सारी सब एरेज में ऑपरेट करना है, ट्राई टू फाइंड सम पॉइंट इन द क्वेश्चन जिस पे तुम अपने क्वेश्चन सब एरे को फिक्स कर सको, ठीक है। तुम उस पॉइंट के लिए कुछ पर्टिकुलर सब एरेज होंगी, फिर कोई दूसरा पॉइंट होगा जिस पे तुम फिक्स रह सको, या लिमिट कर सको, या फिर फिक्स्ड कर सको किसी चीज़ को, और उस पॉइंट से सारी सब एरेज प्रोसेस कर सको, या उस फिक्स्ड चीज़ से फिर कोई और दूसरी चीज़ है उसको फिक्स कर सको, उसकी सारी सब एरेज प्रोसेस कर सको। इस तरह से इसको सॉल्व करने की कोशिश किया करो। जैसे कि इफ़ आई रीड दिस क्वेश्चन, यू विल सी दैट एक जो वीकेस्ट एलिमेंट है, ठीक है। तो व्हाट आई एम सेइंग कि इस एरे में जितने भी एलिमेंट्स हैं, ठीक है, सपोज इस एरे में जितने भी एलिमेंट्स हैं, सपोज एलिमेंट 1 2 3 4 अप टू 10, और जितने भी हैं एन एलिमेंट, हर एन एलिमेंट, ठीक है। सॉरी इफ़ यू आर गेटिंग सम बैकग्राउंड वॉइस, आई होप यू कैन मैनेज दैट, सो टॉलरेट मी फॉर दिस। तो बेसिकली हर एक एन एलिमेंट among n elements will be responsible for the conclusion in our answer, in which way? By being a minimum element, ठीक है। देखो जितनी भी सब एरेज होंगी, ठीक है, कुछ सब एरेज तो ऐसी होंगी जिसके लिए हर एक एलिमेंट मिनिमम होगा किसी पॉइंट पे, ठीक है। सपोज मैं बोल रहा हूँ कि आई एम टॉकिंग अबाउट दिस एलिमेंट, राइट नाउ दिस एलिमेंट इज मिनिमम एलिमेंट, ठीक है। अब मैं चाहता हूँ कि मुझे इस एरे का एज अ मिनिमम एलिमेंट कंट्रीब्यूशन टू माय आंसर चेक करना, ठीक है। मैं इस एलिमेंट को एक मिनिमम एलिमेंट सपोज कर रहा हूँ, ठीक है। अब जितनी भी सब एरेज होंगी, सपोज एक सब एरे 1 बनी, सब एरे 1, सब एरे 2, सब एरे 3, सपोज अप टू 10 सब एरेज थी, ठीक है। तो मिनिमम का 1 के साथ ये सबके सम है, सपोज, ठीक है। सम ऑफ 1 सब एरे, सम ऑफ 2 सब एरे, सम ऑफ 3rd, सम ऑफ 5th, 10th, ठीक है। तो मिनिमम के साथ इसका प्रोडक्ट, मिनिमम के साथ इसका, मिनिमम के साथ इसका, अगर तुम इसको मल्टीप्लाई कर दो, दैट इज़ मिनिमम एलिमेंट को सबसे कॉमन ले लिया, ठीक है, और फिर इसका इसके साथ मल्टीप्लाई कर दिया, ठीक। तो तुम्हें क्या मिल जाएगा? मिनिमम एलिमेंट का टोटल जो कंट्रीब्यूशन है टू आवर आंसर, दैट इज़ राइट। आई नो थोड़ा सा हो सकता है डिफ़िकल्ट हो, मैं एक बार फिर से बताता हूँ। बेसिकली मैंने फिक्स करने की बात की थी, तो इफ़ आई हैव टू ऑपरेट इन ऑल द एलिमेंट्स ऑफ द एरे, तुम मिनिमम एलिमेंट को फिक्स कर सकते हो। कैसे? सपोज कोई एक एलिमेंट है ith इंडेक्स पे, वो कुछ ना कुछ सब एरेज के लिए हमेशा एक मिनिमम एलिमेंट होगा, ऑलवेज, ठीक है। भले ही वो सब एरे वो जो है वो एक लेंथ की हो, सिंगल लेंथ की हो, ठीक है, वो हमेशा एक न एक सब एरे के लिए मिनिमम एलिमेंट होगा। अब अगर मैं बोलूँ कि टोटल 10 सब एरेज हैं जिसके लिए मिनिमम एलिमेंट है, तो उन सब के सम लिख लेता हूँ, ठीक है, फाइन। अब तुम्हें अगर इन सारी सब एरेज का कंट्रीब्यूशन निकालना है अपने आंसर में, तो वो कैसे निकलेगा? सम ऑफ 1 मल्टीप्लाई मिनिमम प्लस सम ऑफ 2 मल्टीप्लाई मिनिमम, इस तरह 10 तक लिखोगे। अगर मैं इन सब से, क्योंकि मिनिमम इन सब में सेम है, राइट, अगर मैं इन सब से मिनिमम एलिमेंट कॉमन ले लूँ तो मेरी ये वाली चीज़ बन जाएगी, राइट। अगर मैं इन सारी सब एरेज का सम एक बार में निकाल लूँ, राइट, तो मैं ith एलिमेंट का कंट्रीब्यूशन भी अपने आंसर में निकाल सकता हूँ। ओके, इन द सेम वे मैं अगर ith एलिमेंट का कंट्रीब्यूशन निकाल सकता हूँ, दैट मीन्स मैं सारे के सारे एलिमेंट्स का कंट्रीब्यूशन टू माय आंसर निकाल सकता हूँ। कैसे? मैं हर एक एलिमेंट को एक बार मिनिमम सपोज करूँगा, राइट। अब जब ये एलिमेंट मिनिमम है, ये कितनी सब एरेज,
वेरी नाइस। ठीक है, सॉल्यूशन देख के हमको समझ आ गया कि क्या करना है, विच इज़ ऑब्वियस। अगर सॉल्यूशन देख के भी नहीं आ रहा था तो फिर तो कुछ नहीं होता, पर चलो सॉल्यूशन देख के समझ आ गया कि हमको क्या करना है। एक बार मैं सॉल्यूशन एक्सप्लेन करने की कोशिश करता हूँ। सो बेसिकली what we're doing here is, let's say we have an array. Okay, now for that array the answer is nothing but, it is basically let's say sum of first subarray times minimum of that subarray plus sum of second subarray plus minimum of that subarray, right? And you do that for all the possible subarrays. Now the answer is also, let's say the minimum, we're going to have the same minimum. So what I'm basically saying is, inside of this subarray, let's say we have 1 2 3 4. Now this one is going to act as a minimum in one of those subarrays, right? Similarly, 2 is going to act in some of them, 3 is also in some of them, 4 is also in some of them. That's all we have, right? So what I can do is I can sort of take this out, and I can say, if I take this out, then I just have the sum of all the subarrays where the minimum is my current index, and sum of all those subarrays where minimum is my current index is nothing but sum of the entire subarray where the minimum is my index. So all I'm gonna do now is I'm going for every index, I'm going to say like that this is my minimum. Now I have to find the largest subarray that includes this index, um, and I'm gonna multiply it by this number. Okay, I'm gonna take the sum and then multiply it by this number. So how to do that is, basically, let's say I have this. Okay, now I'm at this index and I want to find the largest subarray where the minimum element is this index. So that would be from this to this, right? This is my entire subarray where the minimum element is is at this index, and I can find that out easily using, let's say, if I have stored uh, the if I have created a stack that keeps the next greater element, for example, or maybe next smaller element, that could also work. So what I can do is I can check um, for this one, which was my previously smaller element. My previous smaller element is either going to be -1, or since it is equal, so it could it is well going to be this one. My previous smaller or less than equal to element is this, so the next is the left one. So I need to have a stack that can have my previous smaller element. I am going to have a PSC, and I also need a next smaller element. So I need to know these two things. So I'm going to create two stacks um, to achieve that. So let's create two stacks for this problem. One stack will hold my PSC, which is previous smaller element. This is an empty stack right now. So for the first element, the previous smaller element is nothing but previous smaller index element is at index -1 for the first element. Now I can start from for I in range 1. If I don't have a previous smaller element anywhere, then it's gonna be -1. Okay, so now I'm at 1. Now I'm at 3. So the previous smaller element is gonna be uh, I have to say this while length of PSC and find out the previous smaller element. Previous smaller or equal to, okay, so this is gonna be 0, 0th index. I'm gonna say while length of SC and the element, so this is stack, this is S, this is PSC. While length of S stack, while length of stack and strength strength of S of -1, which is top. So top element's strength is less than 3. This is less than equals to strength of I. In that case, I need to do stack.pop. Otherwise, I am going to say if length of stack, then PSC dot append s of -1 as PSC dot append -1 and also stack dot append strength I. This is my stack. Now I want to check what is my PSC. Let's quickly check what PSC is. So previous smaller element for this array 1 3 1 2, previous smaller or equal to element is at 0, previous smaller or equal to element is at 1, previous smaller or equal to element is at 0. This is also at 0, sorry. Previous smaller or equal to element is at 0 1 2 2. So this is what it's supposed to be, but this is not the correct one. So when 3 comes, I do not remove 1 because 3 is greater. So strength of this is smaller. I need to say if this is greater. Now I think the answer is going to be 0 0 2. 0 0 2. So this is previous smaller element for you. Now I need to find out the next smaller element. When is the next smaller element? That would be the previous smaller element for the reversed subarray. Once again, I can say as is maybe length of strength -1. Next smaller element is gain length of strength -1 for I in range length of strength -2, -1, -1. Same thing once again. I will just copy paste the code. This time again, if this is this, then s.pop except that it is. Now let's print the next smaller element. Instead of PSC, I need to do it for NSC, which is next smaller element. My next smaller element in this case, for this case, it is going to be 2. For this case, it is going to be 2. For this case, it is going to be -1. For this case, it is going to be -1. 0, 1, 2. Next smaller element. So if my okay, next smaller or equal to is going to be 2, smaller equal to 2, smaller equal to 2, smaller equal to 0, 1, 2, 3. Okay, so I have this 2, I have 2, then I go to 1 and I check if the top element is greater than 1. Yes, it is. In that case, I pop, which is not correct. I think I should just figure out. Mm, मैं भी तो सेम चीज ही कर रहा हूँ. ये ओवर स्मार्ट क्यों बन रहा है? यहाँ पे for 1, यहाँ पे I want the next smaller element. तो उस केस में क्या होगा? Previous smaller element. तो 1 तो है नहीं, है ना? तो 1 के केस में previous smaller element है नहीं. तो 1 के केस में 1 ही तो हो जाएगा, लेकिन 1 के केस में अगर स्टैक में कुछ नहीं बचता तो I डालो. यहाँ भी I डालना चाहिए ना फिर मेरे को. Print PSC, NSC. Previous smaller element is, so PSC is previous smaller element. Previous smaller element is 0. For this, previous smaller or equal to element is 1. This is 0. Oh, this is, sorry, 0. And for this is 2. Right. And the next smaller element is at 2. Why does it say 3? Next smaller or equal to, smaller or equal to. So this goes to this. It says greater element is 3. This is also saying 3. This is basically saying 2. And for this it is 3. Why does it say 1? This M2 has while ST and STP of top is greater than I. Okay, for 1312, my previous smaller element is 0, 0, 2, 2. So for this is 0, for this is 0, for this is also 0, for this is 2. That makes a lot of sense. And the next greater element is 3, sorry, 2, 2, 2, 3. Okay, so for this, the next it is 2, for this is 2, for this is 2, and for this is 3. So that makes a lot of sense. Okay, and f equals to list reversed NSD if you want. I don't know if I really want that or not. But anyways, now I need to figure out the answer. So answer is for I in range length of strength of I. Okay. Now I just need to find out the left. So the left is going to be C. For any index, let's say 1, 3, 1, 2. For any index 1, I need to check which was the previous smaller element. So the answer is going to be 0, right? The answer is going to be 2 because it was equal to 2. But this is going to ruin everything. Isn't it supposed to be 0? It was supposed to be 0. If it's gonna return 2, that won't be really helpful. It's supposed to return 0. Okay. Now left is gonna be, I need to find for the current index, which was the smaller, so that would be PSE of I plus 1, right? What is the right? Right is gonna be greater value. Um, right is simply gonna be NSE of I. Sum is gonna be prefix of right minus prefix of left, isn't it? Why do I have this thing? I need to find PSS. This is really annoying. I need to find PSS also. And then I plus 1 minus left times PSS of right minus PSS of I plus 1. PSS of right plus 1 minus PSS of I plus 1. This times the left and right times the left. That multiplied by ST of P. Wow, that is too much. I fear that I might have exhausted my entire energy just to solve this one problem, which is insane because it wasn't even that tough. But that's the reality. I've exhausted my entire energy. I will have to stop streaming now. Goodbye.